Hi there, seventh graders. Let's continue our discussion on scales and make sure we really thoroughly understand what a scale factor is. Okay, so what happens when you have a scale is you have the original, which is usually bigger, and we usually draw a scale that's smaller so that it's easier to deal with. That doesn't have to be the way, but that's usually what happens. Like here's the state of Utah, huge. I can't even hold it out in real life because I'm in it right now. We draw a map of Utah. The map of Utah is not actual size, it's a scale. But a scale works by a specific ratio, which is the scale factor. So today we're going to make sure we really thoroughly understand what a scale factor is and how to find it. To do that, you need page 65 and you need some pens and pencils or whatever you're using to write with. So here we go. Okay, right away I have a definition for you to write. So pause me if you need to write it down. Go ahead. I'm now going to read it out loud. It says a ratio comparing a scale length to a corresponding actual length. That should sound familiar to you. Scale to actual. In fact, I'm going to annotate it a little bit and just kind of underline the important words here. First important word is a ratio. Well, a ratio. Okay, we've dealt with those since like 5th grade now at this point. Did it a lot in 6th grade, did it even more this year. A ratio is a comparison of two numbers by division. We usually write them as fractions. Okay, a ratio comparing scale length to this is the fancy word, corresponding. Corresponding just means matching. Which one does it go with? So comparing a scale length to a corresponding actual length. Scale to actual, we make a ratio out of it, and that one ratio becomes what we call the scale factor. And the scale factor helps you determine if something is getting larger or if something is getting smaller. So let's look at how we actually write a scale factor and what we use it for. Practice problem number 1. Anna drew a smaller picture of an image of a car that she found. Determine the scale factor of her drawing. So here's the original car that she found. So obviously with these kind of measurements, this is not an actual car. It's just being called the original. So we also think of that as the actual. Okay, so I'm going to write that here. This is like the actual, what we've been talking about. Actual. Okay, and this is her drawing. So Anna's drawing becomes the scale. Actual, scale. Okay, so the scale factor here is length on the scale drawing. Well, here's the thing. People look at that and they go, well, which one? I see 2 values there. You're not wrong. I see 2 values there too. This is where this keyword of corresponding becomes so important. I'm going to pick one from the scale. It actually doesn't matter which one I'm going to pick, but I'm going to pick one. 6 centimeters. Okay, here's where that keyword corresponding comes in. I'm actually going to write it right here. 2 R's, corresponding, corresponding to this leads to this. So it doesn't matter which one I pick first, but it absolutely matters which one I pick second. That's that corresponding there. If I pick 6, I'm not going to pick this one because those don't correspond. 2 and that one, yes. 6 and 10. Scale to actual or original. Okay, so the scale factor here is 6/10, but of course we simplify that. And when you have a scale factor, you simplify it down and it's just the constant value. That's why it has its own definition. The ratio here is really 3 centimeters to 5 centimeters. That's how we could write it out as a whole scale ratio. But when we're just writing the scale factor, we just put it as a constant value. Shawl's falling off. Okay, put it as a constant value. Scale factor is 3/5. Or sometimes it's also a little more clear if we make it a decimal. This is a scale factor of 0.6. That means you could also think of it as a percent. We've done so much talking about percents. These all go together. That means her drawing was 3/5 of the original size, or 0.6 of the original size, or 60% of the original size. Because it's smaller than 1, smaller than 100%, that shows you that her scale drawing decreased the size by a scale factor of 3/5 or 0.6 or 60%. Her drawing decreased the picture by 60%. scale factor. Fraction, decimal, percent, they're all good because they're all just different ways to write the same thing. Let's use the other set of corresponding sides. I didn't pick them because it has a fraction in them and I just didn't really want to, but they're telling me to for a specific reason, and I'm going to share that with you now. So the other set of corresponding sides would be here and here. Once again, we do scale to actual, 3 1/3. Well, scale to actual, let's see if I can get that to a better number here and get it to just a nice, okay, so here we go. 2 divided by 3 1/3. Oh, you guys can't even see what I'm typing. There we go. I just used the fraction buttons. And look at that. It came out as 3/5, which I'm not surprised by because it's the same thing, but this is still 3/5, 0.6, or 60%. So it doesn't matter which piece you choose to work with first, but it really matters that whatever you put with it as a ratio is a corresponding piece. Corresponding. You got to pick matching stuff. If I didn't match them up, I wouldn't have gotten the same thing. Okay, let's try this again. Flip it over. We can do this again. This is not a super complicated topic. It's pretty quick, but we got to make sure we get it. Determine the scale factor of the drawings below. Practice problem 2. Here we go. This is original. Let's write it again. Original is what we've been calling the actual. Now, so I'm saying that because sometimes we confuse it like actual is supposed to be in real life. Obviously, there's no such thing as a, what's this, an ambulance? I don't know, van of some sort. There's no such thing as an ambulance that's like this. So again, this is just the actual because it's the original. It's how it started. This one came to this scale drawing. This is actual, this is scale. Okay, maybe this is a picture that was blown up as a scale, enlarged. All right, so let's find the scale factor here. Well, I need to pick corresponding pieces. It doesn't matter which one you start with first, but it definitely matters that whatever you pick first here, pick the corresponding piece here, length, length, or height and height. And then be careful. We keep saying scale to actual, scale to actual, scale to actual. Which one was the scale? 5 inches. Actual or original was 2 inches. 5 to 2. Oh, that's a scale factor of 5/2 or 2.5 or 250%. And you know what that means? That means it got bigger because it's over 100%. That means it got bigger. It was an enlargement, not a reduction. All right, let's try one more. Original, what does that mean? That means actual. There's my actual, there's my scale. Right away, I can see that this is a reduction, not an enlargement. And they were nice and only gave me one measurement, so I don't even have to pick. This definitely corresponds with this because they will all be the same. It's a regular octagon. So I do scale to actual. 5/10 is 1/2 or 0.5. Or guess what? This was a 50% reduction. And because that was so fast and so easy, this is what you're going to practice on your Canvas quiz. So use those notes. But to save us a little bit of time next time, because that was pretty quick, I actually want you, I know, so exciting. We're going to move on to page 67 too, Ms. McGowan. You're the best math teacher ever. I love when you let us move on, right? Page 67, let's just look at one example here and then we'll save the rest for next time, okay? This is where things start to get a little bit more complicated, scale drawings and area. Partially because this requires us to remember, and I'm going to write up here, that area, we're going to learn and make sure we remember a lot more areas. The areas you're going to have to worry about are just of a rectangle. So you remember length times width, areas length times width. That's again something you've done all through elementary. That's the only type you're going to have to worry about here. As we move further into geometry, you're going to get much better at areas, but not yet, not yet. One thing at a time. So let's just look at practice problem number 1. In Micah's drawing of his room, 1 centimeter represents 2 feet. Oh my goodness, look what they're giving me right there. Step 1, write the scale. Notice it doesn't say scale factor. It just says what's the scale. That's this part that they gave us, 1 centimeter to 2 feet. That's the scale. Okay. Here, is this his real room, do you think? Is this his actual room, 3 centimeters by 5.5 centimeters? No, this is his scale drawing. This is the scale. This is not the actual. Okay. Set up proportions to find actual the length. I think those words are backwards. The actual length and width. I know the scale. I want the actual length and width. Well, why do they have 2 separate proportions? Well, because, and I'm going to color code this, you guys all know how much I love to do that, because I actually have 2 things I'm finding. I'm finding the length first. That is going to use this proportion. Okay, let's focus on that for just a second. Look what I do. Scale to actual. That came from my scale. Scale to actual. So then I come over here and I say, okay, scale to actual. Which one is the length? Well, traditionally, this is called the length. I'm doing it all in this like peachy pink color. So scale to, do I put 3 right here? No, I want the length and I put an X right here. Actually, I could put a squiggly L. That's what I could do for length. That's how we write them in geometry. You got to do a squiggly L because guess what? If you just do a normal L, it looks like a 1 and that is confusing. So I'm going to do a squiggly L. This is my scale, 1 to 2. This is my scale. And this is trying to find my actual. Okay, so here's what we did. Scale to actual for the scale that he's using, scale to actual to help us find the real one for the drawing. Okay, this is the scale he's using and this is the drawing. I know that word scale gets used in different ways. It's the same word and it has a few different meanings. It's confusing. But now we know we're going to cross multiply right here. And that's going to be 1L, which is actually just L, equals 5.5 times 2, which is 11, and that's 11 feet. We just found the actual length. His bedroom is actually 11 feet. Okay, let's use a different color and let's find the actual width. Actual width. Okay, guess what? I start like this, 1 to 2. 1 to 2. All right. And then now I'm doing width or height. Sometimes we call it height. So now I'm doing 3 over W. And what's the actual width? 1W equals 6 feet. So I just had to do 2 separate proportions to help me find the length using the scale of 1 to 2, and then again with the width. Now, the last thing we need to do is calculate the area of his actual bedroom. Well, how do we find area? Length times width. Now that we know those actual measurements, we can just multiply them. 11 times 6 is 66, and that is now in square feet. Okay, I think that's probably enough for today. So you're going to practice scale factors like what we did on these pages. You're going to practice scale factors on your Canvas quiz. And then tomorrow we'll come back and work more with scale drawings and area. If you have any questions, please ask me.